All right, guys. Shh. Table 1, what did you guys roll? 5. Table 2. Table 3. 12. Okay. Sorry, I can't hear apparently. Table 4. 11. We got some high roll in here. Table 5. Ooh. Are you guys okay? Table 6. 9. I knew that one actually. Table 7 hasn't gotten a chance to do it yet. Table 8. 3. Table 9. Ooh, matchy. And then table 7. 3. Okay. This is kind of a weird graph, but I meant it to be weird because I didn't want it to be anything special or have you think that I was doing anything special. It's just totally random. I'm going to call the shape of this uniform. Okay. What I need you guys to do is in your groups, I need you to put 3, 3, 5, 9, 9, 10, 11, 11, and 12 into L1 and run one variable stats, please. It doesn't have to be everyone. It could just be one person. Yes, when Riley's done. This is a great time to review this concept from chapter 1, making sure that you know how to enter data into L1 and run one variable stats and find all of these things. Did you guys get a mean of 8.1111111? Okay, just checking to make sure I typed them in correctly. Can someone out there in the world check my work and tell me thumbs up if I did it correctly? Good, I did, okay, because, you know, I've been known to make a mistake here and there. Okay, all right, what we're going to do today, so that's our review right there. First of all, we randomly rolled the dice. We have 9 times here. I really didn't want to do 9 because that's going to make repeating decimals, but you know, it's okay. I can get over it. Now we're going to extend this to chapter 2, and we're going to learn 2 things today. We're going to learn about what happens when you add or subtract a number to a data set. So what I mean by that is, like, on the next one, we're going to add 3 to all the numbers and see what happens. We're going to take all of our dice rolls and add 3 onto that and see what happens to the shape, outlier, center, and spread. Then we're going to take our data and we're going to multiply it by a number and see what happens to the shape, outlier, center, and spread. All right. It's not too bad, I promise. Homework. Why is that right in the middle? Why is that? Why is that? Why is that? Oh, there's a little Homework is 21 to 31 odd and 33 to 40. Okay, you should know the format of the textbook. When you have a bunch of problems like that through, most of them are multiple choice. So usually it goes some odd ones, then a set of multiple choice, and then the last 2 are usually like a review problems, just so you know the format of the textbook. So don't freak out thinking, my goodness, it's 33 through 40, that's so many. Most of those are multiple choice. don't worry about it. Anyway, here's my joke of the day. It says, and here's the chart that shows what you might see if you look at a mountain range through a tennis racket. Thank you for fake laughing. I thought it could look kind of like the cumulative relative. Okay. There's gonna be better ones, I promise. Okay, so now we're gonna see what happens when we add 3. I'm gonna give you time. I'm gonna give you time. Do you guys have it to here?
Yeah.
Okay, I'm gonna give you time to set up the rest. Don't worry. Okay, what we're gonna do is we're gonna take all of our original dice rolls and we're gonna add 3 to them. So these 2 3s are going to become 6s. Does that make sense? Okay, then this dice roll of a 5 is now an 8. And these dice rolls of 9s are now 12s. And then 13, and then 2 14s, and a 15. Okay, I want you guys to enter these and find these answers, please. So clear out your L1. Yes. So clear out your L1. Shape is still uniform. Okay. Did you get it? Did anybody get? Are you needing more time? We're good. Okay. Now I'm going to pretend to be a statistics overlord. And just from my knowledge, looking at this dot plot and the original dot plot, I'm going to guess your answers for. I'm going to guess your answers for these items. Okay, it looks to me like my graph shifted up 3 units, so my mean would shift up 3 units. Okay, I'm good so far. Next, I notice that my graph shifted up 3 units, but they did not get more spread out, which means that the standard deviation did not change. Can you guys tell this is the same width as this? Okay. Now, what's wrong with it? Did I do it?
No, he's calculating.
Oh, okay. All right. The minimum looks to me like it shifted up 3 units to 6. The median shifted up 3 units to 12. The max shifted up 3 units to 15. And the IQR is a measure of spread, so I'm assuming it stayed 7. Okay, my goal for today is for you to be able to fill that stuff out if you're asked to without putting it in your calculator. Just knowing that you added a number, picturing that shift up the x-axis or shift down the x-axis. So when you're adding and subtracting a number, this is the most important thing. It shifts up or shifts down, but does not get more spread out. Good? Okay, now I'm gonna mess with that. And I'm gonna give you some time to set this up because this is a giant number line. Mrs. Talbot, why did you use a 12-sided die anyway? Because it's fun. Gotta put it back in my pouch of weird die. I literally have a pouch of weird dye. See? And this, by the way, is a times, this dot here. Okay, guys, so the first thing that we rolled was a 3. We rolled 2 3s. 3 times 2 is 6. So I have 2 6s. The next roll was a 5. 5 times 2 is 10. Am I making sense? You guys okay? My next roll was 2 9s. 9 times 2 is 18. My next roll was 1 10. 10 times 2 is 20. I had 2 11s, which would be 2 22s. And then I had 1 12, which would be 1 24. Okay, shapes uniform. Go ahead and go in the calculator. Type these guys in and fill it out. And then I'm going to see if I can guess what they are first. Jake, you have to get you a water bottle.
I know, I ran out. It's not good.
I'm sure that he does. His mom bought me one of these gifts. Okay, so this time, I'm hoping that you notice 2 things. I noticing that the numbers shifted higher, but they also got more spread out. So that's what I'm hoping you notice. I'm hoping you notice the numbers got bigger, our rolls, but they also got more spread out. So here I'm going to try to predict. I think your new mean is probably twice the original mean, so 16.2222. Yes? Okay. I think that your standard deviation is twice as spread out. And I just want to show you guys real quick. Here's my original spread. So from here to here, and I'm here to here. So twice the amount of graph paper squares. And it was, I don't know how to multiply decimals, 3.5158 times 2, 0316. Is it not? Is it rounded differently? 16? I got 17. Okay, the reason is because I rounded on that first one and then I used a rounded number to round again, so it's okay. Okay, the minimum now I can tell is 6. 2 times bigger. The median is also going to be 2 times bigger. It was what, 9? So it's going to be 18. The max is going to be 2 times bigger, so 24. And then the IQR is going to be 2 times bigger, which is 14. I did it. It's like I have a crystal ball or something over here. Okay. Does anyone need more time with this page? You good?
Yeah.
Okay. Okay. It's arts and crafts time. Thanks to Mr. Talbot. If you could find the very last page in your packet and just pull it off. Mr. Talbot again has made our lives easier by suggesting that I type some of these up for you so that you don't have to write the whole thing. He's trying to save my carpet tunnel. It's the very last page in the packet. Just rip it off. All of these are problems we're going to put in our notebooks. I've given you guys supplies. You can either glue it in or tape it in, depending on your preference. I suggest leaving 3 lines underneath this bullet point here for us to write in what we're going to write there. Seems to be going slightly uphill. What's going to do about that? Arts and crafts are fun. The key is going to be not to lose this paper with the rest of your problems on it. Yes, honey. Just the first one. Does it make sense like what day they're on?
Yeah.
Okay. So like Thursday, oh, by the way, I have excellent news. You guys do not do the math test in these stats. I am teaching things, but no math. Oh, no, how did I put you? Okay. Stats. When we signed up for stats. Okay. You guys ready? Okay. Archie back up on. Owen, give me the thumbs up when you're ready. Just Owen. Just Owen. Okay. All right. So let's put in a summary of what we learned from our dice roll activity. So okay, so bullet point one, adding, subtracting a constant or multiplying, dividing a constant does not affect the shape. So if it was uniform, it stays uniform. If it was right skewed, it stays right skewed. If it's symmetric, it stays symmetric. Does that make sense? Okay. Okay, understand that this is going to sound a little collegey right now. Adding and subtracting constant, so adding 3, minusing 3, multiplying, dividing a constant times 2, divide by 2. Both of those affect the measures of location. It would do us a lot of good to list some measures of location so that we know exactly what I'm talking about. So, for example, min, max, mean, quartile 1, quartile 3, those are all statistics that have to do with location. So a coordinate point, one coordinate point. Median, let's add median. Excellent job. You guys doing okay with my symbols too? Okay. Okay, so this is pretty much the whole point of teaching this right here. When we added and subtracted the numbers, you guys remember they did not get more spread out, right? So adding and subtracting doesn't affect the spread. So you have to resist the urge to add or subtract to the spread. Again, resist the urge to add or subtract to the spread. Because if you remember, when we added 3, they did not get more spread out. Okay. So let's name some measures of spread. Standard deviation, IQR. What's the last one that I don't like very much? Range. And would you believe me if this was the end of the notes right there? So all we have to do is this one example and then we're done. Okay, so we're going to apply what we learned to an example. So this is my favorite, the formula is the Fahrenheit to Celsius business. This is very important. It's called I just taped this, but it's fine. It's called a linear transformation. Can anyone tell me an intelligent reason why this would be called a linear, think back to math, not that, linear transformation? What do you know about line equations? It's been a minute. Close, yes. Y equals mx plus b. Okay, if you think about this, you have y equals mx plus b. Okay, now why did I pick this one? I picked this one because it covers both of our things. It's got an adding 32, so it's got an add of a constant, and it has a multiply of a constant 9/5. You could think of it as multiplying and then dividing, but I don't want to. I just want to do 9/5 as a multiply. Okay, so we have both things happening here. We have two transformations. We've got a shift up 32, and then we have a multiplication of 9/5. Okay. A city has an average temperature of 25 degrees Celsius with a standard deviation of 3 degrees Celsius. Use the formula blah, blah, blah to describe the temperature distribution for this city in Fahrenheit. Okay. Do we know the shape of this distribution? No. So we're just going to say the shape in degrees Fahrenheit will be the same as it was for degrees Celsius. We don't know what it is. We don't know what Celsius was. It doesn't say, doesn't give us a graph to know, but we do know from what we learned today that it's going to stay the same shape. Good? Okay, do we know if there's any outliers like crazy hot days or crazy cold days in this city? No, but we do know that outliers in the original are going to still be outliers in the new distribution. The outliers in degrees Fahrenheit so whatever outliers there were in Celsius, those same values, once they're plotted on the new graph in Fahrenheit, will be outliers also. We can't find them, it's okay. Okay, now center. Center is location. I'm putting that little note there so you can jot your mind to go up here. Okay, so center's location. Adding and subtracting and multiplying and dividing both affect measures of location. Okay, so in Fahrenheit, my average is 25, so that's my center, my mean. So it's going to be 9/5 times 25 plus 32. It's basically like a function machine. I take my 25 and I plug it in the Celsius spot, and that is 77 degrees Fahrenheit. Okay. You're like, why is that special in Excel? It's special because you multiplied and you added. You multiplied and you added only because it was the center. Okay, now the spread, you're gonna have to resist the urge to add or subtract. You don't add or subtract. This is the moment right here. I got 3 from that, by the way. It's a standard deviation of 3. Don't add 32. It's not going to get plus 32 more spread out. Okay.